Right, today we are going to move on from where we left off last week in chapters 2 and 3, and we're going to move on to chapter 4. Chapter 2 and 3, remember, focused on methods of displaying categorical data, data that falls into categories. Today, chapter 4, we're going to focus on ways to represent or ways to display quantitative data. So data that actually has to be measured, data that contains units. So we are going to just go through all the different types. Some of them you may know, some of them you may not know already. The first one is called a histogram. A histogram looks similar to a bar chart. Remember from last time, remember in a bar chart or a bar graph, the bars are separated. The bars are not connected to each other. Whereas in a histogram, as you can see here, the bars are connected to each other. So the data is clumped into groups and the bars touch, unlike a bar chart. And what makes a histogram useful is it can show you what the shape of the data is, and we'll talk more about what that means in a minute. We also have something called a stem and leaf plot. You may have remembered learning about this, probably in middle school sometime. You may have learned to make a stem and leaf plot. The data is organized from greatest to least, and each leaf represents a single data item. So the way we read a stem and leaf plot is, for example, up here, usually the stems are the first part of the data point, and the leaves are the second part of the data point. So this data point right here would be 88, and then we would have 80, 80, 80, 80, 84, and 84, so on and so forth. That's how we read a stem and leaf plot. If we go further down, we would have 60, and then 64, 64, 64, and 56, so on and so forth. So each of these represents these kind of the second digit of a single data item. Sometimes, very often, we'll see stem and leaf plots that have what we call split stems. So in a stem and leaf plot that doesn't have split stems, they'll have, for example, all of the 80s together and all of the 70s together, 60s, so on and so forth. But notice here, they split. So all of the data items between 80 and 84, okay, the first half of the 80s are in one group, and then all of the data items in the upper 80s, so 85 to 89, are in a second row. And then it goes down from there. So this row right here are all the data items from the upper half of the 70s, so 75 and above. And then here we have all the data items from the lower half of the 70s. And it kind of goes down from there. When we split those like that, upper half and lower half of the 80s and the 70s, so on and so forth, we call those split stems. All right, so that is a stem and leaf plot. All right. Now, what's interesting about a stem and leaf plot is that it actually, depending on how you orient it, actually looks the same, exactly the same as a histogram. Here, up here, we have a histogram and a stem and leaf plot of the same data. And if we play around with the orientation, so watch what I do here. If I rotate the stem and leaf plot so that it's upside down, and then flip the histogram upside down, notice they have the exact same shape. So if you take a stem and leaf plot and a histogram of the same set of data and you flip it so that it's upside down, like I did here, okay, you'll see that they show the exact same shape. They look almost exactly the same, except this one has bars and this one has your numbers written down. So that's kind of a unique thing about stem and leaf plots and histograms. Okay, a dot plot is what it says it is. Okay, it's a plot of all of the data items, kind of in graphical form. A dot plot, a dot plot also will show the shape of the data, and again, we will talk about that in a minute. So a dot plot just simply shows, for example, all of these dots represents data items that have the same value. Whereas this particular dot right here, there's only one value, one of those values in that set, so on and so forth. What do all of these do? What do all of these displays do? They aim at helping us describe what we call the distribution of a set of data. Remember, and we're talking about quantitative data, data that is measured. And when we want to describe how a set of data is distributed, we want to look at four different things, and I'm going to talk about each of these individually. The first one is called the shape, and I mentioned that earlier. Then we have something called unusual features. Then we have the center of the data, and then we have the spread of the data. And like I said, we're going to go through each of these four things individually, starting with the shape. Right? So a shape, the shape of a data, is essentially is how one of the parts of the shape is how many modes the data has. You might remember from probably middle school, you learned about something called the mode, and the mode was always we would always refer to as the number that occurs the most, the number that occurs the most in a set of data. So when we talk about how many modes, we could have a shape or a mode that is uniform. We could have something called unimodal, and we can have something that is called bimodal. And they're all pretty self-explanatory, and I have a picture example of each. So for example, data that has a uniform shape. So uniform, when you think of the word uniform, when you think of a sports team wearing the same uniform, they're all wearing the same shirt, the same design. So a set of data that is uniform means all of the data is either the exact same value or very close to the same value. So that's what we refer to uniform. They're either all the exact same value or all very close to the same value. Okay, a set of data that has a shape that is unimodal, and that's the picture that I have in the middle here, the histogram in the middle. You can see it just means it has one set of data that occurs the most. In a histogram or a stem and leaf plot, you'll see it has one high point. If it has one high point, that means it has one set of data that occurs more than the others, which makes it unimodal, one mode. And obviously, we could have many different types of modes. The last one I have here is bimodal, bi meaning two. So a set of data that has a shape that is bimodal means it has two modes. It means it has two pieces of data that occur more than the others. In a histogram, like I have here, it'll have two high points. So, you know, if a set of data is trimodal, that would mean it would have three modes, or the histogram would have three high points. So when we talk about shape, we're looking at first how many modes it has. Is it uniform? Is it unimodal, meaning one mode, or bimodal, meaning 2 modes, and you could have more than that. A lot of times what we'll do is if a histogram or if a set of data has more than one mode, we'll just usually refer to that as multimodal. Multi meaning more than one. But you could also be specific, like bimodal, trimodal, quadrimodal, so on and so forth. The other thing we want to talk about when we describe the shape of a set of data is not only how many modes it has, but also whether the data is symmetrical or not. I know you all know what the word symmetric means. I have data is symmetrical, meaning meaning you can fold it on itself. It looks the same. The left and the right are mirror images of each other. So here I have a histogram that we would describe as roughly symmetric. If I drew a line down the middle, both sides would be mirror images of each other. Is it perfectly symmetrical? Obviously not, but it's pretty darn close to symmetrical. So whenever you have any sort of histogram that is either perfectly or pretty darn close to symmetrical, we would describe that as symmetric. So this particular histogram here, we would say that it's unimodal because it has one high point, and it's symmetric. You could also have data that is asymmetric, that is not symmetrical. And when data is not symmetrical, we call that skewed. And data could be either skewed to the left or skewed to the right. When we want to describe what direction the data is skewed in, we always look for what direction the data tails off in. So for example, in this middle histogram here, notice most of the data is to the right and then it kind of tails off to the left-hand side. We would describe this histogram, we would describe it as unimodal because it still has one high point, but we would describe this as skewed to the left because it tails off to the left. Whereas this histogram right here, notice, is the exact opposite. So most of the data is to the left, and then it tails off to the right. So we can have data that is symmetrical, or we can have data that is skewed. And when we want to talk about the direction of the skewness, it's always what direction does it tail off to? If it tails off to the low end or the left, we call it skewed left. If it tails off to the high end or to the right, we call that skewed to the right. So all that combined tells us the shape. How many modes does it have? And is it symmetrical or is it skewed? So that's the shape. The next part of the distribution that I talked about earlier is the unusual features. And when we talk about unusual features, we talk about outliers. And this is a word you may have heard before. So in a histogram or in a data set, if you have a piece of data that is kind of way far off from most of the other data, then we would consider that an outlier. So for example, in this histogram here, notice most of the data is kind of off to the left-hand side here, but then there's this one piece of data that's way higher than most of it. We would call this piece of data right here an outlier. And usually if you have an outlier, that means there's a gap. So you can see we have the histogram, then we have a gap where there's nothing, and then we have this outlier way at the top here. So if you're asked if a piece of data has unusual features, what they're really asking is, does it have any gaps or outliers? Okay? And if you have a stem and leaf plot or a histogram like we do here, it'll be abundantly clear if there's an outlier. Just like we have here, there'll be a bar that's way off, in this case, way higher than the rest of them. Okay, so those are unusual features. The center of the data, the center of a set of data is kind of what it is kind of what it's kind of in the word. The center is where is the center of the data, and when we talk about how we can measure where the center of the data is, we can look at the median, and we of course know that the median is the middle number of a set of data, or we can look at the mean. And you, of course, know the mean is when we add up all the numbers and divide by however many there are. On a histogram, the center of the histogram is usually where the mode is. It's where I like to think of it as like the balance point. Like if you were to take that histogram and try to balance it on one of your fingers, where would you have to put your finger in order for the histogram to be balanced? On a picture, the center is going to be not the literal center of the histogram, but where the mode is. Okay. When we want to actually measure what the center is, if the data is skewed, then the median, the middle number, that will be the most accurate representation of the center. So that's only when the data is skewed. When the data is symmetric, then we will use the mean. The mean will be the most accurate representation of the center. Okay. If the data is unimodal, the center is where the mode is on the histogram. It's the high point. So it's not necessarily the literal center, it's where that mode is. Okay? So that's the center. And then, of course, we have the spread. And the spread, again, is what it says it is. The spread is essentially how spread out the data is. And just like with center, we have two different ways that we can accurately measure how spread out the data is. One of them is called the interquartile range, or IQR for short, and the other is called the standard deviation, which you may have heard before. So I'll talk about the interquartile range first. Okay, when you have data, of course, you know that the median is the middle number, but the interquartile range is what it says here. It's the difference between Q3 and Q1, Q3 minus Q1. So if you can imagine, if you had a bunch of numbers and you ordered them from least to greatest, you could take that set of data and you could divide it into quarters. Okay, so the Q1, the first quarter, that would be like where the 25th percentile is. Okay, the second quarter would be the middle. Okay, that would be the median. The third quarter would be kind of the 75% mark, the 75th percentile. So if you take the value that's at the 75th percentile, the 75% mark, and you subtract the value that's at the 25% mark, that difference is called the interquartile range. Okay? We consider that to be where the middle 50% of the data is. Where did I get 50 from? Well, what's the difference between 75 and 25? 75 minus 25 is 50. So again, the interquartile range is the difference between the 75th percentile, the 75% mark, and the 25th percentile, the 25% mark, or Q1, first quarter. When I get confused, I kind of think of the quartiles or the quarters. Think of it as like a basketball game, okay? Q1, when you play the first quarter, at the end of the first quarter of a basketball game, you are 25% of the way, of the way done with the game. Okay, when you reach halftime, that's the median. That would be like the end of the second quarter. Okay, and Q3, quartile 3, when you reach the end of the third quarter of a basketball game, you're 75% of the way through the game. The interquartile range, whatever that value is, that is the most accurate representation of how spread out the data is only when the data is skewed. Okay? When the data is symmetric, the measurement that we use for how spread out the data is called the standard deviation. Okay? Now, you may have heard of the value of what the standard deviation is. Standard deviation, the definition of the standard deviation is how much the data varies from the mean. In other words, how spread out a set of data is from its mean. So if the data is really tightly clustered, all really close to the mean, it's going to have a very low standard deviation. When it's really spread out from the mean, okay, not close to the mean, then it's going to have a high standard deviation. And again, that standard deviation, that value is going to be the most accurate representation of the spread only when the data is symmetric. Okay? So, to sum up, okay, we talked about mean and median, and we talked about interquartile range and standard deviation. Okay, and it depends on if the data is symmetric or skewed. So I kind of summed that up here. When the data is symmetric, and I have an example of that here, when the data is symmetric, then we use the mean and the standard deviation. In other words, the mean and the standard deviation are the most accurate ways of measuring the center and how spread out the data is. When the data is skewed, and remember, it could be skewed left or skewed right, but when the data is skewed, we use the median, which is the middle number, and we use the IQR. Again, that's the difference between the third quarter and the first quarter. Okay, so the median and the IQR, those will most accurately measure the center and how spread out the data is. Okay. So I talked about all of this stuff. Mean, median, standard deviation, so on and so forth. I talked about all the different ways of displaying quantitative data, histograms, stem and leaf plots, dot plots, etc. But we never talked about how to calculate all this stuff. So that's what I want to show you. That's what I want to show you here. And what we're going to use for this chapter is we're going to use Google Sheets to help us make these hard calculations. I'm never going to make you calculate things by hand. I'm not going to make you calculate standard deviation by hand or mean or median, so on and so forth. We're going to use the technology. To help us. I'm not interested on whether you can calculate those by hand. I'm just interested in, can you interpret what those values mean? So in a minute, I'm going to show you how to calculate all of this stuff using Google Sheets. So if you go to your Google Drive, you can open up a Google spreadsheet. Okay. So I opened up a Google spreadsheet here, and what I'm going to do is I'm just going to enter 10 random numbers. Okay, it doesn't matter what the numbers are. Okay, so I just entered 10 numbers, and I'm going to show you how we could use Google Sheets to calculate all the things that I talked about. So the first one is the mean. Remember, the mean is when you add up all the numbers and divide by however many there are. So when you have a small number of numbers like we have here, it's not too bad to do by hand. But when you have a very large list of numbers, it can be long and tedious. So that's why we use technology. So what I'm going to do is I'm just going to go to a separate cell over here. And if we want to calculate the mean, we hit the equal sign, we type equals mean, or excuse me, equals average. And remember, average is another word for the mean. So equals average. And then what I'm going to do is with my mouse, I'm going to highlight all of the values. So I'm going to highlight all the values that I want to find the mean of. Okay. And then I'll close the parentheses, and then I'll hit enter. And you can see it tells me the mean or the average. So of the numbers that I typed in here, the mean is 15.2. Okay, so that's how we do mean. Okay, so median, we're going to do the same thing. And actually, that's a typo here, so I'm going to fix that. So it's equals average. So median, we're going to do the same thing. So I'm going to go to a blank cell. I'm going to type in equals, equal sign, median. And notice that pops up here, equals median. And again, I'm going to highlight the numbers that I want to find the median of. And I'll close the parentheses, and I'll hit enter. And it tells me the median. It gives me what the median is. Okay. Standard deviation, again, same thing. So I'll go to a blank cell, and I'm going to type equals STDev, which is short for standard deviation. So equals STDev. Okay, and you can see that pops up as one of the options here. Notice there's other options down here, but we want equals STDev, which will tell me what the standard deviation is. And again, I will simply highlight the numbers, close the parentheses, and hit enter. And it gives me the value of the standard deviation. Okay. The last two things I'll show you are the quartiles. Okay. So your first quarter, your Q1, your 25% mark, and your Q3. So if I want to find, for example, Q1, the 25% mark, I'm going to type equals quartile. Okay. And if I type in equals quartile, this is what I'm going to choose here. Okay. And then once again, I'm going to highlight the numbers. Okay. But this time it's going to be a little different. Okay. I'm not just going to highlight the numbers, close the parentheses, and hit enter. After I highlight the numbers, I'm going to type comma 1. Okay. This tells me that I want to find the first quarter, the first quartile, the 25% mark. So after I highlight the data, I'm going to type comma 1. Then I can close the parentheses and hit enter. So you can see this is the first quartile, the 25% mark. Okay. If I want to find the third quartile, all right, the third quarter, the 75% mark. Okay. Again, I'll do the exact same thing. So I'll do equals quartile. So I'll choose quartile. And once again, I will highlight the numbers with my mouse. And I will type comma, and then I'll do 3 this time because I want the third quarter, the third quartile. Then I'll close the parentheses and hit enter. So this right here is my Q3, and this is my Q1. Now, the only bad thing about Google Sheets is that the only thing it will not calculate is the IQR, the interquartile range. So, even though it won't calculate the interquartile range, we know that the IQR is the 75% mark subtract the 25% mark. So I found those values up here. So all I would need to do to find the IQR would be to subtract 23.75 minus 4.25. Okay? I could do that on a regular calculator and find the IQR. So that is how we will calculate all this stuff. The only one that you'll actually have to do is the IQR. Everything else, the mean or the average, the median, the standard deviation, and your two quarters, the first quarter, the Q1, and the third quarter, Q3, can all be done on Google Sheets. So when you have to calculate things like that on your assignment, make sure you use Google Sheets to help you. It'll make your life a lot easier.